sold that way, you had to buy a new machine, or you had to be an OEM. So everybody downloaded it. We all found it somewhere. But then you had to reformat your hard drive and reinstall. Remember that? To get 32-bit. All right, so 98 to 2000. 2000 workstation, either XP or 2000 wasn't supposed to exist. Neither one of those was not supposed to exist. The reason 2000 was released early was they had a piece that was missing that they could not get working. And the vendors who wrote software, Norton, Symantec, all these other companies, they were pissed off because it had been in development for 4 years. And it was supposed to be the end-all of all the platforms. And so it had been in development, and they weren't releasing it because they had this one piece that was not working. Do you guys know what the piece was that wasn't working? You can probably guess really quick. What is Workstation not good at that XP is good at? Because they are the same core. They are the same basic. What's that?
Backwards compatibility.
It's not backwards compatibility except with one thing. What did Windows 95 have in it that was like the big claim to...
I can't remember everything, but I think I'm on the right track.
Yeah. Windows 95, one of its biggest things was that it could play games. It was the first real version of DirectX, right? DirectX allowed you to poke a hole through the software to the hardware, because if you interfere with it with APIs, it slows your system down. That was the advantage DOS had, was it was faster with games. But when you get to Windows 95, they had made DirectX to do this, right? So DirectX plays a role throughout all of our versions of our OSs at that point from then on. And they have stopped, delayed, rebuilt, and done everything based on DirectX so that people could play games and talk to hardware. And so Windows 2000, DirectX did not work. It was a terrible release from a standpoint of playing games. So they released it as workstation and server. So it could not really play games at all. So they had to keep developing DirectX to get it to work in the flat memory and the 32-bit operating system that they ported over from Windows 95 and Windows 98. And that's why XP was released. So when they tell you XP means experience, DirectX and XP, X is not X is used throughout all of Microsoft's products, and it means one particular thing every time they use it, right? That DirectX is part of the platform. And Xbox is DirectX with a slimmed down OS. That's why it's an Xbox. That's what it is. It's DirectX in the box. So Windows XP is the first version. They had to have compatibility with everything else. It lived. It's still alive. It's been alive for 14 years now. And if you get rid of compatibility, what was one of the biggest selling tools that everybody had to have? You guys remember the tool list? The biggest and most popular tool that ever existed for PCs in the 90s. What? I mentioned it already once. Where all good products go to die. Partition Magic actually. So Partition Magic came from PowerQuest. It wasn't the best-selling utility. It was actually fairly new at that point, but Norton Utilities, right? You needed Norton Utilities to keep your system alive, right? It repaired your disk, it backed up your FAT tables, and people would defrag their systems, make it faster. It was like everybody had Norton Utilities. Everybody used Norton Utilities, and here's the thing: Norton Utilities fix stuff on the fly without asking you any questions. So if your partition structure was screwed up, it automatically fixed your partition structure. If you move to LBA blocks and you get rid of CHS, and you get rid of legacy stuff, you get rid of LBA 28-bit mode and 48-bit mode, if you get rid of all of those things and you say no longer does a partition have to begin, because when we went to LBA blocks, a partition did not have to begin on a cylinder boundary. That's because of CHS, so that one head could stay on one side of the platter to make it the same. We got away from physical. Physical no longer existed. We went to logical block addressing. That's why it's called logical block addressing. It's sequential, and it doesn't matter where it is on the disk. But if you started up a tool that expected that calculation to work, it would eat your data. You guys understand this, right? That's our legacy problem, is tools like that. Partition Magic, Norton, all of these other repair tools, all the things that expected the disk layout to be a particular thing. You can't move to a new OS and expect no one to carry the software that they had with them. They always carried their software with them because they're not going to reinvest that. That's why PCs can run previous versions of their software. So, in this particular instance, if you get rid of cylinder boundaries and you start up any one of those tools, it will eat your data and you will lose it. And that would be a catastrophe. So we maintained control of that all the way up until Vista was released. When Vista is released, we now have multitasking, powerful processors. We have systems that can track what you run. Norton Utility is no longer popular. None of these things played with disks anymore. They all made all of their commands through APIs. But what is the first thing that Vista started doing when you would upgrade to it? You guys remember one of the things that Vista did that you had to check to make sure you could run Vista? What is that? You could convert to dynamic disk, but that wasn't really what I meant. What I was getting at is that
Hardware compatible.
yeah, whether or not the software is compatible with your hardware and the list of things you can do, and immediately its operating system could interfere with your ability to run an application. So if you had an application that was on the disk that made a particular disk call, it would actually kill it on the fly and would say, pop up a box and kill it. We didn't have multitasking, until we were in XP and other stuff, but at that point that was a re-release of Windows 2000 basically, with a bunch of additional stuff added. So those were all pretty quick and pretty close together. So by the time we actually get to this spot, you've got software that starts saying, I can't run this piece of software. And they disabled a bunch of stuff. You used to be able to actually debug. Debug, disabled. Can't use debug anymore. Try to use it. It'll kill you. It'll stop the process because you have an emulator running DOS. You can't execute it. It kills it. You can't run a lot of applications. It'll put them in an incompatibility list and it'll kill them. And then starts protecting memory. So it starts doing things you can't do otherwise. And you pretty much know at this point, you just have to give up if that piece of software doesn't work. There's a couple of tricks you can do, and it must have been compatible with something else, and that's about as good as you get. Otherwise, you got to go back in time and make things work. So you can't magically make that happen. So the reason that this is important is because we are dealing with partition tables and repairs and all this other stuff. Now, by definition, where's the fastest location on the disk? Outside edge, right? When you make a partition, normally it's going to be closest to the outside edge of the disk, right? So sector 63 on most NTFS systems is the first location for your partition. So we have MBR, we have a GPT if it's going to exist, then we have sector 63, and right here sits your first partition. So if you want a second partition, it must begin on a cylinder boundary. So by definition, it must be inside the edge of this disk. So if you have a 32 gig partition and it exists here, now you've got another partition inside of here. By definition, what is the second partition compared to the first partition?
Slower.
It is going to be slower. Absolutely slower. There is no way you can say this, based on physical attributes, that it's going to be as fast as the outside partition. So when people test stuff, it really matters what they're testing. It matters where they're writing their data. And this is where other things come in as a problem. There's database managers. You heard of that job? Database management, and the people who are supposedly figuring out how they can best run a database. And Google and some of the other companies have some really smart people that are there doing this function. But the other guys are management information systems, and those guys who are database managers, they have no clue how these jobs work and what this stuff is. So here's the mistake they all make. Every one of them, because no school understands it and nobody teaches it. If this was a RAID array, it works identically to a single drive. If you have a RAID array and you disperse the data across the drive, wherever those sectors are on the outside edge are the fastest. The closer you get to the center of the disk, the slower it's going to be, even across 4 drives, because they're segments, and they're all the way across the 4 drives. So, if somebody installs a server, the first thing they do, they make your OS partition the first partition. Then, they'll make the second partition the installation utilities that they're going to use to install for everybody else's software, right? The third partition they make is the user partition. The fourth and the fifth partition they make is Exchange Server and SQL Server. That's what I see every time. That means you just put the 2 most used, most written databases in the slowest part of the disk. So all your activity now happens right here. And the very least used stuff is the user partition and your installation in your OS. And those are here. So the very first thing that you do, if you want to prove, you're a super IT person, reverse that process. Move your partitions from the inside to the outside, and your Exchange server will get 20% faster. So will your SQL Server database. Those two components are the most used. They write constantly. They never stop. They have their own. The JET databases and the stuff they write in there is basically a file system in and of itself inside those databases. So just keep in mind all of these things associated with speed are super important. Now back to cylinders, heads, sectors, LBA blocks. So you have to get rid of this theory that we have to have a partition that exists on a cylinder boundary. So Vista comes along and Vista says you can't use any of these. I can make a partition anywhere I want now. So legacy stuff we've had for 30 years no longer works. So I can put a partition here, I can put a partition here. So you have a process that no longer equals the calculation. It used to only take a couple of seconds to search for a partition, but now if you want to search for a Vista, Windows, XP, 7, 10, any of those, not XP, any of those, you will have to search for every single sector. You have to do excessive searches. So if you know which operating system is on the drive, you need to make that choice. In my mind, I'm going to try to make a quicker choice no matter what. I'm going to try to do the quickest thing possible to get this recovery back without me having to waste time. And if you click that button, you will have to search every sector for a partition structure. You'll see this as we're going through it. You'll understand what I mean as what the value of this is. So partitions had to begin on cylinder boundaries. The next partition is going to be slower by definition. Now, why is this a problem? Why? So understand Microsoft is working with hardware vendors. They want to get rid of 512-byte sectors. You guys understand that, right? Everybody wants to get rid of a 512-byte sector because with a 512-byte sector, you are limited to reads that are not equal to your clusters, and it is slowing the system down, and they cannot track them. There's too many sectors to track. If you have 512 bytes and you have a 16 terabyte drive, you've got to track 16 terabytes of 512-byte sectors. Well, wouldn't it be better if we had a 4K sector or we had an 8K sector? So this drive actually existed for a long time before it was released. This drive existed for about 2 years before it was released. They built this back when Vista was released. In 2007, 2008, they were building these drives, but they couldn't release them because no one could use them, because they can't use them with XP. I don't know if any of you noticed these labels and what they say and what they mean. These right here, there's a chunk. Did you guys ever read this stuff? This is what it says. Advanced format drive. To achieve performance, you must, under Windows XP with a multi-partition and cloning software, use the WD Align software. This is the drives that are out today. These are on the shelf. You go buy one now, most likely this is what you're getting out of these drives. On a single partition, you can set the jumpers prior to installation. Prior to installation, 7 and 8. This will corrupt your partition structures if you do not do this. If you do not do that and run this software, and you try to run it on anything pre-Windows Vista, this will not work. It will cause all kinds of problems for your software. And what do you think they're aligning? You know what they're aligning? WD Align. That should have been a clue to a lot of people right there. Your partition must begin on a cylinder boundary. If you are doing 512-byte sectors, but now you switch to a 4K sector, every native read is one read for 512 bytes. But if you have an overlap, you have to do 2 reads. So you have multiple reads and an alignment problem of your partition structure because your partition structure no longer begins on a cylinder boundary. XP expects it to be on a cylinder boundary. So when it moves its clusters around, it expects it to work on cylinder boundaries. You guys understand what I mean? So here's the effect. So why did they get rid of 512 bytes? Remember the one thing I told you every manufacturer wants to do?
Save money.
Yeah, they want to make their disks bigger at your expense, whether or not it's safer or not, so that they can get a bigger disk and get some of those gains back. So this is what it looks like. Now this is a smaller version of my version of the sector. When I showed you a sector earlier, so 512 bytes, there is a sync dam, there is a location where there's a sync dam and there's a sector gap, and there's no bytes in between it. If you get rid of individual 512 bytes, you don't have to have the sync dams between every one of them. So you take the 512 bytes for 8 sectors and you squish it together, and you make that. Now you only have a sync dam that's smaller. You still have the same amount of ECC. You still have the same equal amount that you have to write to a sector for ECC. But if you do 4K in a chunk, you get rid of all the sync data in between. Okay? How big in a 512 byte situation here, how big is a bad block? You lose 512. If you have a bad block, it is 512. How big is a bad block? 4K. You lose 4K if it goes bad. So there's all kinds of repercussions from this that are going to happen. Now, here's the gain that they got from doing this. They thought in calculations it would be close to, and that's what they said originally, is they were going to gain about 20-something%. If they got rid of that data in between, what is that math and everything going to work out to? It turns out they only got about 11%. They did not get 20% of a gain back. They got 11% of the drive. But at the same time, realize the sacrifice that you're paying for that 20%, for even 11%. You just sacrificed a bad block from 512 to 4K. You sacrifice the partition structures and legacy hardware. You can't install these in your legacy hardware anymore if you want to go back and run anything older. So we lost that ability. But more importantly, we lost the ability to maintain integrity in our files and the data, because we've now switched from 512 bytes to 4K, that we will lose 4K chunks. Now, it will read natively, so it will be faster. We gain speed. But Microsoft and all of its OSs still, to this day, right now, still read and write in 512 byte chunks. So they have to write a chunk. It has to take, it can't write a single, this is the smallest writable sector. You can't write 512 bytes. You must write to a chunk of memory, have 4K, and the 4K will be readily available and slam it down on the disk. It's the smallest writable unit. That's what a sector is. That's the definition of a sector. Smallest writable unit. Okay? In this case, it is also equal to the smallest erasable unit. So you erase a sector, it is 4K. You cannot erase 512 bytes. You have to put it in a memory, modify it, put it back down. You understand? Now this is where solid state changes the world. Solid state is based on a mathematical grid. And the grid, the way it is laid out, is not laid out in logical sectors. It's laid out in a grid that you must erase an entire row at the same time. And so they're bought in blocks. And so if you want, and it's because it's a mechanical or a electrical thing, you're going to put a charge down a drain line, and sectors, in order for the sectors to erase, electrons are going to have to escape from the cells. So they're designed in chunks, in blocks, multipliers. So if you have a 2K sector or a 4K sector, you have to multiply by its blocks, which is going to end up being 64, because that's what everybody's buying now as a multiplier. So you have a grid that is divided up into 64 grid items in a grid. So 64 times your sector size. So if your sector size is 2K, it's 128K. So your smallest erasable unit is 128K. You guys understand what I'm saying? So that's where all this is starting to happen. It's starting to impact us. But this, so if you're looking at your partition structure and you get rid of cylinder boundaries, then you're going to do this. This is why there's a problem for cylinder boundaries. If you read and write a location where your partition starts and ends, right? If it overlaps beyond the extent of equal numbers of 8 sectors. In other words, your partition starts here in XP. It will overlap to here if it's reading in 4K chunks. This causes 2 reads to occur instead of 1, or 2 writes to occur instead of 1, because the overlap for this position now believes is part of this. This can cause corruption because it's not a single sector anymore. This is why you have to use the jumper or you have to use the software to realign it, to disable or re-enable or to realign a 4K chunk. You see my point? We have an MBR. No matter what, your partition cannot begin where the MBR is. So you are always off by at least one, no matter what. So you are always into a second sector, no matter what, when you read and write. You guys getting the point? That's one of the reasons why it's throwing off. So now, when you actually go to search for a sector or you go to do something, you have to, I'll give you an example. Let me use, here, let's do this. I'm going to use get data back. File system identification. That means what kind of partition do I have? That's what that means. What are my file systems that are on this hard drive? If you're going to scan and build a structure, now this is where it makes a difference. Do you have Vista or do you have anything later than Vista? Or do you have XP and something earlier? Because you can save a tremendous amount of time if you do this. So if you do not check this box, it knows cylinder boundaries automatically. They never needed this box before they had Vista because there was nowhere else for it to go. It would search automatically cylinder boundaries. Do you have a partition? And it was very quick because there's only like 263 choices. So it was done instantaneously. If you say excessive search, it does every single sector on the drive without making a copy. Like you're actually looking at a drive. If you're looking at an original drive and you did this, and you said go, what it does is, at this point in time, is it's going to search every single sector on the entire drive for a partition, whether you've touched it or done anything at all, for partition structures. You get my point? Yeah?
Yes, sir. You just mentioned the speed, like putting, like database on the outside and
yes.
putting the OS. Well, how do you do that? How do you determine that, like, if I go to my system administrator and I have, like I'm running a database and
how do you see where your things are?
How will I do it? How will I
how would you
somebody to do it?
How would you know that it's there? Is that what you mean? Like, how do you know? Or how do you make it happen?
How do I make it happen?
Okay, first thing is, if you're here, the layout of your partitions, this is actually logically in order. This is 0, and that's the highest LBA numbers. So if you actually look at your partition structures, even on a RAID array, and you see boot, user, blah, 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 exchange server, then it's in the slowest part of the disk. That's actually a physical layout of your content. So you can actually image the partition. And you don't have to C does not have to be the first partition, and it doesn't have to be the bootable partition. You can actually have your bootable partition be D, E, F. You can make it be whatever you want it to be. You know that, right? It doesn't have to be C. So you can make a bootable partition here if you need to. So what you do is you pre-make a huge partition that you can delete and change later, and then make your system partition here. If you already have a system that's running, then you image the partition. You understand what I mean?
No.
So let's say you have a 32 gig C drive. Let's say it's 32 gigs, and that's your C drive. And then you have other stuff, and you want to reverse those. Now you have two methods. You can either reformat, reinstall, and make that partition out here. Like you just make a dummy partition, and then push it out to here. And then you use those partitions as you install other software, right? So you make that partition the partition you're installing and booting. Now, if you already have that and you already want to make that work, then what you do is you do like this. You go and you start up a tool like FTK Imager. You go and you add your drive. You can even do this on a RAID array. It works perfectly fine on a RAID array. You come and you image this partition. And you make that partition an image or a disk image. You can make the actual partition itself the image. Understand? So you make the image. So you actually have the bootable sections. you make exactly the same size further down on the disk, and then you restore the image. And then that's your bootable. You set it active in the MBR, and you boot it. And then you make all your other partitions backwards. It's easier if you're starting fresh. But if you're starting with something, then you have to restore it.
So if I'm starting fresh, like my C, I can put my database, I can make my B bootable, is that what we're saying? I can put my own.
Yes, so letters mean nothing, they're just logical, right? So letters you can assign or you can do whatever you want everywhere. So the letter means nothing. If I want to change this letter, I can actually change this and make it whatever I want, right? And it doesn't matter what's bootable. The partition structure in the MBR doesn't do it by letter. It does it by position. So it knows where it's at. It says cluster starts here, ends here. That's what it says. So all you're doing is making a partition that's bootable further down the disk. So, understand my point? Try it. You can do it. You can start up. When you start up to do an installation, just go ahead and make 3 partitions and then tell it the partition you want to install is the 3rd partition. And it'll do it. There's not really a trick to it. People are just so used to only doing it one way. You just use your advanced options, make multiple partitions. You know, the Windows 10 version just goes, I'm installing, and there's no questions. But outside of that, I don't know what we're going to do. I didn't try it like in advance. Yeah, right. We know. Right. We are Microsoft. Right. We are Microsoft. We do what we want. Right. We will tell you what we want. So anyway, so that's the point. That's all you're trying to do. Until you can reverse that position, then your drive will be faster on the outside edge. You can test it. Literally, you can test the speed. You will see right away. The outside edge is faster, without a doubt, 3-4 times faster in some cases than the inside edge, even on a RAID array. But all of this is just virtual stuff that's just in your mind. It's actually, this is the matrix. Take the blue pill. You can do whatever you want, okay? But that's all I would do. You can do, there's a bunch of tricks you can do with RAID arrays that people, IT guys know some of these tricks. Like for instance, if you have a RAID array, and it's, let's say you have 4 drives, 4 gigs each, and you have a 16 gig RAID array. If you want to make your RAID array bigger, what you do is, and I'm not suggesting you do this without having a backup, you rip out one drive. You take one drive out. You put in a bigger drive. You put a drive 2-3 times the size. You put whatever drive size you want in. It will resync the partitions, and when it's done, you'll have the original same size. The 4 gig is going to be there on a 16 gig drive that you just installed. Then, after it's finished syncing, you rip out the next one. Then you put in another 16 gig drive. You wait for it to rebuild. So a day later, then you pop out the next one until you're done with all of them. When you are done, that virtual space is available. That virtual space at the end for the rest of the 16 gigs for each one of those that's available will be available in its entirety. You just have to make a new partition. It actually comes to life. You guys know what I'm talking about? Have you seen this before? That's how we used to do in-place upgrades on RAID arrays. We used to physically just rip them out one at a time, wait for them to resync to a bigger drive until we do it. Now you have potential for failure. But once you've done this a couple of times, you'll see it almost always works. But there's that one time. Almost always. There's that one time where something didn't work out right. So, but it does work. There's things like that you can do. And then you can make that second one further down in the disk or whatever else you want to do. There's all kinds of tricks to that are IT tricks. But anyway, so that's literally what we're looking at as far as our options as we're going through this. That overlap is actually what causes the problem. You can do testing with this by using Bonnie++, booting on a Linux disk. You can actually test your disks, and you can see your zone tables, and you can see your sectors. You can see where they are. You can also see the difference between USB drives and internal drives. Now, Bonnie++ does not plot this for you. This graph is plotted based on the material that it outputted. These were not graphical. They were numeric, and then they were plotted. And you can see, there's a couple of things you can see right away. Like for instance, you would expect that there is a time frame between here and here that there is going to be latency because your head turns off and it moves to another part of the platter, right? But you see that one? What is that probably? Huh?
Towards the outer edge, right?
It's in the first zone, and there's a problem. Do you know what that problem might be?
This move.
Could be a bad block, right? It has to go to another part of the drive, read it, and come back. So you have a time differential between where that's going to exist and that's going to exist. And so as you see this, you would expect it between those, but if it happens in the middle of something, potentially that's a bad block. So you could tell right away from its numeric data. So for instance, on this one, USB, right? Now, here's a couple of things that it could be. First thing is, I have been told by a manufacturer to my face, the drives that are in USB enclosures are the drives that failed more in our divisions when we're making drives. Like if it has more failures and it has more bad blocks, they know you can't check it easily in an external enclosure because USB didn't support that and it's special commands to do it. So they would put them in the external enclosures and they would sell those as good drives. So this isn't new, like every manufacturer does this. They do it with thumb drives, they do it with everything. You don't think that the memory that they're selling to you is as good as what they sell to Cisco?
Okay.
No, I promise you it's not. When they make NAND, they give the good stuff to the OEMs. They pay more, but the good stuff is out there in the OEMs. That's in the casino machines and in the routers and you want it that way because your little thumb drive is really not that important. It's really not. Would you rather your Cisco server or your Cisco router die or your thumb drive? I'll take the thumb drive, right? So that's what's happening. That's the same thing. The bad drives are in USB enclosures. I don't know if it remains true because there's so many external sales now, but it's certainly they're selling the good stuff as OEM stuff to all the vendors. Apple's getting better tested drives than they're getting from other people. So I don't know if that really means anything these days. They're all the same. But keep in mind, these are the kind of tests you can do, and those might be bad blocks. And that also explains why external drives die more often than internal drives, besides the fact you move them around or carry them around. Okay. All right. I don't know if he has food here yet. Did anybody see him come in? Let's take a quick